All right, here we go. Let's get our note sheets out. Let's kind of pick up where we left off yesterday, which is in part 2. We're ready for problem C. Now, when you see this notation, you are immediately going to think an ordered pair. I mean, that's what I would think. I would think that's the point -1, 3. But this actually is an example of what we call interval notation. Did you use interval notation before? Interval notation is simply a more efficient way of writing a set of points. This means everything between -1 and 3. In other words, that's just another way of writing this. This would be set builder notation, you know, if we put all this stuff in there. This is just a quicker way of writing that. So when you take your calculus class, your solutions are probably going to be written using interval notation. So this means the same as this. The parentheses represent open circles, and then of course it means everything in between -1 and 3. Okay, good. Now, when you look at problem D, you'll see a little bit of difference. What's different about problem D? There's a bracket. Guess what the bracket means?
Closed circle.
Closed circle. So when you graph this one, you'll put a closed circle at -2, still an open one at 6, and you'll shade everything in between. So this means everything between -2 and 6, including -2. Interval notation. Parentheses mean open circles, and brackets mean closed circles. Now, what in the world is going on in E, do you think?
Infinity.
Well, if I were going to graph this on the number line, I know absolutely I have a closed dot at 4, right? But what? Where's that other dot go?
Same place.
It doesn't stop. There is no other dot. This means everything less than 4. That means all the numbers that are less than 4. The infinities, negative infinity and positive infinity, are always open dots. When you write an interval notation and you're trying to describe, you know, everything less than 4, everything greater than 6, you will always use an open dot with your infinity. You can't ever really get to infinity. That's why it's an open dot.
Should it be greater? Ever be greater than, or is it always less?
Yeah, oh no. If it were greater than, you would have a situation like this. 6 comma positive infinity.
Okay.
Put a bracket here. So it would look like starting at 6 and then going all the way to positive infinity. So it would look like that.
Right.
What if someone wanted you to graph this? What would that look like?
Just a line.
That's the whole number line? The whole thing. That's everything. So the times when, think back, when you answered a question by saying all real numbers, that would be the answer in interval notation for all real numbers. That's everything. Okay? That's pretty easy. All right, now, write as an inequality. So this is kind of the same thing, but instead of drawing it, you're going to write it as an inequality. Now, if it helps you to draw it, do that. The fact that these are parentheses, means these dots would be open, which means the symbols you're going to use do not have the or equal to, right? We're going to use plain less thans. When you write a compound inequality, This means, kids, if you think about this, this means everything between 4 and 6, right? So you're going to put X between 4 and 6. It isn't hard, and it never looks any different than that, except sometimes we have the or equal to's. But you simply put the numbers in the same order, little, big, put X in between them, because that's what you're talking about, the numbers in between, and then less than symbols. Every time. So what about, oh, I just did this one. Just did it. Right here's the next one. That means everything starting at 6 and going to infinity. So in other words, we're going to have a closed dot at 6 headed to infinity. What would that inequality look like? This is an inequality. What would that look like for this problem?
X is greater than 6.
Greater than or equal to 6. There's your inequality. X is greater than or equal to. Why is it an equal to?
Because the bracket is.
Because of the bracket. That's exactly right. All right, let's look at this picture now. Can you write this? Can you write this as either an interval or an inequality? For the problem, we really need to do inequality, but let's practice interval too. What would that look like? Either one. Who can do one? Yes. Negative 1 comma 5.
And it would be a bracket on the right side.
Exactly. Everybody okay with that? That's interval notation. That is not the inequality. That's the interval. Everybody okay with that? All right. Now, what would the inequality look like? That's this kind of thing. What would that look like for this? Jalen?
Negative 1 is less than X. X is greater than 5. Or X less than 5.
Less than or equal to 5? There's what it looks like. We're going to write that as one piece. When you graph it, it's only one piece. So we're going to write it as one piece. We're going to put X between negative 1 and 5. And we got to put an or equal to on that one. Remember when you write your compound inequality, that's got 2 numbers in it, so it's called compound. When you write your compound inequality, you're always using less thans. And this one has to have an or equal to because it's a bracket. All right, interval notation. This is the inequality notation. That's called the inequality. It's got the inequality symbol. What would that look like in terms of an interval? Oh, shoot, I gave it away. They're parentheses, right?
Yep.
Because there are no or equal to's. So that would be just 4, 9. How about this one?
Bracket, -3, -6.
Remember when we write our interval notation? These numbers always are in the order they appear on the number line. In other words, you would never see this. This would be, you would never see that. That doesn't make sense. The numbers have to be in the order they come on the number line. Same thing when you write your compound inequality. These numbers have to be in the order they come on the number line, in the regular counting order. Jalen?
We'll never see the same, like, we'll never see a 3, 3.
Why would you? What would that
I would
mean?
have, like, that, like,
Well, I don't know. Well, what would that mean, Jalen?
it's only 3.
It would be only 3, right? That's right. All right, and finally, we're going to write this one in interval notation. Positive 2, shaded that way. So what's that going to look like in interval notation? Bracket at 2, because that's a closed dot. You got to pay attention. It's a closed dot. And then a positive infinity. Parentheses. Remember, the infinities are always open. That's a little math technicality, but it's an always. So you shouldn't mess it up. It's always open when it's an infinity. All right, good job. Everybody okay with that? Okay, next. What is the additive inverse of -3 plus pi and 16? Anybody know what I mean when I say additive inverse? So, I think you know.
Pi minus 3.
Another word for additive inverse is the opposite.
So pi minus 3 or pi plus
So the opposite of this would be, yeah, you could,
negative pi.
yeah, I would just say 3 minus pi probably. I wouldn't turn things around. But by opposite, we mean if it was positive, it becomes negative. So negative 3 becomes positive 3. Positive pi becomes negative pi. So what's the additive inverse of 16? Negative 16. Gang, gang, gang. That is not hard stuff, right? Additive inverse is the opposite. Speaking of not hard stuff, we have the distributive property. Now, we know what that means. When we distribute, we take whatever's outside the parentheses and times it by everything that's inside the parentheses.
Yep.
So what happens when we take a 3x times a 4x?
12x squared.
We get a 12x squared. That's exactly right. 3 times 4 is 12. X times x is x squared. Plus, now we got to take this times this, so we get now look at B. Mrs. Ford, there's no parentheses. Well, guys, the distributive property works both ways. So in this case, we multiplied this across the parentheses. What we're going to do here is factor. Factoring is the distributive property in reverse. So this has already been distributed, undistributed. What would you do? What can you factor out here? If you want to create a parenthesis, the only thing that can come out is an x, and you would then be left with 5x minus 8y.
Yeah.
That's the distributive property too. The distributive property works both ways, either multiplying through or factoring out. That's the distributive property. All right, so C. What happens here?
You can take out an a squared and a z.
We can take out an a squared and a z.
Yeah.
Everybody good with that?
Yeah.
So what's left if we do that? Now remember, you're taking out an a squared and a z.
A plus Z is 4.
So you'll have an a left here, and a z to the 4th left here.
Yes.
And of course, you could always check your answer, right? By doing what? Multiplying it back together and making sure that that's what you come up with when you multiply it back. D. Distribute it. Here we go. 10x to the third. Everybody good with that? 10x to the third minus
6x squared y.
6x squared y. Perfect. All right. What can we take out?
You take out negative 32.
Can we take out a 32?
Yeah.
Does 32 go into 160?
Yes.
Okay, how many times does 32 go into 160?
5.
5. So we're going to take out a 32. Remember, you have a calculator, right? So Ms. Ford's not expecting you to know that 32 is a factor of 160, but you certainly could check it. So 32 you said goes in 5 times. This is going to be 5a minus b.
Yep.
And then F, and I know you're all thinking, oh my gosh, Miss Ford, this is so easy, it's so boring. I thought you were gonna teach me some real math. Well, guess what? Somebody's gonna miss this problem. Because no matter how many times your teachers say, distribute the negative, people are gonna forget. You must pay attention to this right here. Everybody will get this right. Everybody will say, yeah, that's negative 6x. But this is gonna be what? Plus 21y. And I know you know that, you just have to make sure you're paying attention. Okay, oh boy, now we got our exponents. Alright, so here we go. Let's take a look at problem 7a. Everybody still with me? Alright, so 7a, here we go. We're going to do some canceling. Whenever we have x's on the top and x's on the bottom, we're going to cancel. Okay? Now I know there are rules for exponents. Okay? But sometimes we get those confused. So sometimes it's easier just to use our common sense and not worry about the rules. Here's the common sense. Look at your x's. How many x's are on the top? How many x's are on the bottom?
2.
So when you start canceling, think about it, you've got 3 x's over 2 x's. When you start canceling, who has more x's, the top or the bottom? The top. How many more does the top have? 1. So you're going to have 1 x left on the top, because there's 1 more x on the top than there is on the bottom. Now what about the y's? Same concept, except now the extra 1 is on the bottom. So your answer is xy, x over y. Remember, when you divide, you subtract exponents. That's the rule. But I'm telling you, you don't even need to know the rules if you have some common sense and just think about what's going on. All right, what about this? Now, this is a little wild and wacky here. Anybody have a thought on this? You've done all this before, so somewhere in the back of your mind, you've got this. What? I heard somebody say something about flipping it. And that's exactly what you want to do. Why are we flipping it? What's making me flip it? The negative exponent flips the fraction. Remember, when you have a negative exponent, if it's in the numerator, that moves that thing to the denominator and vice versa. So if you have a negative on the whole fraction, then that means this is going down and this is going up. So step 1, I would strongly recommend, is that. There's always more than one way to do the problem, and it doesn't have to be done this way, but that makes it the easiest, I think. Whenever you have a negative exponent, flip it so that the exponent is now positive. Now, this is a quantity raised to a power. Remember, that means everything in the quantity gets raised to the power, right? So this is going to be x to the second, y to the second, over, do not screw this up, the bottom will be 9, 3 to the second. Somebody's going to say 6. Yep, you're right. But it isn't 6, it's 9. Now, as complicated as these problems look, if you take it one step at a time, just slow down and take it one step at a time, you can do these. You can do these. All right, so here we go. What might we think about doing first?
Multiply the square to
Get this guy taken care of?
yeah.
All right, so again, that means square everything. So this is gonna become
X is 16.
16, x
to the
to
fourth.
the 4th. And then we still have our y to the 5th, and we still have our 4x squared.
Four squared.
Now, 16 and 4, don't overcomplicate it. 16 divided by 4 is 4. So we're gonna have 4. On the top, 16 is the big number, right?
Yep.
So when you do your division, knows where the big number is, that's gonna be 4. If this had been 4 over 16, the 4 would go in the bottom.
It'd be 4x to the second, y to the fifth.
Exactly. We got x to the 4th over x squared. So think about it, you got 4 x's over 2 x's. When you start canceling, where are the extras gonna be? On top. There'll be 2 extra ones up there on the top. And I can't do anything with my y, so I really don't need that line, do I? So that would be my answer. Somehow I'm thinking you guys aren't quite as excited to be doing this as I am, but that's all right. Everybody's tired. Okay, we got a whole weekend to rest.
Oh, we good.
Maybe we were probably up late last night doing summer reading,
Exactly.
or maybe not doing summer reading. I don't know what your philosophy on that is, but anyhow, at least we don't have to do the quizzes anymore, right, or the tests or whatever. Was that easier?
No.
No. Yeah. My kids, I had 4 kids go to school here, they all hated it, summer reading. All right. Here we go. This is a mess. We are not going to panic. We're going to take it one step at a time. A little bit ago, Mrs. Ford told you that there's always more than one way to do a problem, and you're welcome to do it however you want. But the easiest thing to do is to deal with the negative. Now, this whole fraction isn't flipping because the whole fraction is not to a negative power. What is moving are these individual elements. So that, because he has a negative exponent, is going to go to the denominator. So x squared is coming down. Y cubed is coming down. Now notice when they come down, they become positive exponents. Now the z is going to stay up there. Don't move the z. He has a positive exponent, right? Same thing, this x to the 4th is staying down here. He's not moving. He does not have a negative exponent. This one does, so he's going to the top. This one doesn't, so he's staying on the bottom. Everybody with me? We're only moving things with negative exponents. Don't make it hard. Only move them if they have a negative exponent. Now, we probably have some combining and canceling to do. Let's go alphabetically. Let's look at our x's first. Now, you're not canceling any x's because you don't have x's on the top and the bottom. You only have x's in the bottom. How many x's all together do you have in the bottom? 6. Somebody said 7? How'd you get 7? There's 6 of them down there. You've got 2 and 4. Right? Those are my x's. So I'll go ahead and cross those out. Notice they're on the bottom. Now let's look at our y's. What's going on with our y's? Well, we got some y's on the top and some y's on the bottom, right? Who has more? Top. How many more? 2. So we're going to have y squared on the top. And now let's look at our z's. I got 1 on the top and 6 on the bottom. So that will leave me with 5 on the bottom, and there's your answer. Nicely done. These problems look overwhelmingly difficult, but if you take them one at a time, you can do it, one step at a time. Math is not a race. Alright, so here we go. Are you going to flip it?
No.
No. No, you're not going to flip it. It does not have a negative exponent. So you're just going to cube everything. So what do we have on the top?
X to the 8. 16.
Want you to think about it, kids. It's x squared times x squared times x squared. Isn't that what we're doing when we cube? We multiply it times itself 3 times?
Yeah.
Now how many x's is that all together? That's x to the 6. So again, we have these rules. But if we get the rules mixed up, if we can't keep the rules straight, don't use the rules. Think about what you're doing. You're taking x squared times x squared times x squared. That's x times x, x times x, x times x. That's 6 x's. X to the 6. Over.
27.
Thank you so much. That's a 27 down there. That is not a 9. It is 3 to the 3rd. 3 times 3 times 3. That's 27. That is not a hard problem. You've done problems like that before. Those of you that don't have your brain fully engaged, though, are going to miss that. One step at a time. All right, last one in this section. All right, what do you want to do with this guy? Flip it. Of course we're going to flip it. We have a negative exponent, so it's going to be x over 2 to the 2nd. Alrighty. And then what?
X squared over 4.
X squared over 4. Absolutely perfect.
Okay.
Alright, now we got a little scientific notation going on. You have all had chemistry, so every single one of you is a scientific notation expert. So we want to write this number in scientific notation. You can tell me what it will be.
3.14 times x times 10. Second?
1, 2,
Third.
3, 4, 5. 10 to the 5th. You got to move that decimal point 5 places, right? So that's going to be 10 to the 5th. Now, sometimes kids say, oh, the score is a positive 5 or negative 5. I'm going to move it left, move it right. Forget all that stuff. If it's a big number, it has a positive exponent. If it's a little number, it has a negative exponent. So 0.716 or 7136 is a little number. This is a little number. So whatever I have is going to be times 10 to the negative something because it's a little number. How many places do I have to move the decimal to get it in the right spot? 1. So it's 7.136 times 10 to the negative first. Now we're doing some arithmetic with scientific notation. Now you always have many options. You can do whatever you want on this problem. Let me show you what I think is probably the fastest way to do it. But it's not about speed, it's about what makes sense to you. So here's what I would do. I would take my, where's my trusty calculator? Oh Lord. It's the first day of school and someone's taken my calculator. No, I have more calculators, so I always keep mine right there. it at this point. No, I know it was there yesterday, somebody used it. Hopefully not stolen it, that would be really bad. Okay. Maybe this is before I accidentally picked it up. We'll see. Okay, alright, so I'm gonna multiply 3.16 times 1.43. So I'm multiplying this number times this number. And then I'm going to divide by this number. So I'm dealing with just the numbers. And when I do that, I get 3.6738. I'm going to round that off because it actually has a whole bunch more than that. But I'm multiplying the 3.16 times the 1.43, and then I'm dividing by the 1.23. Is that okay with everybody? Now I'm going to figure out how many tens I have. So I'm going to do the tens separately. So on the top, I have 5 tens, and oh, wait a minute. What's going to happen to those tens?
They're gonna subtract.
They're going to go to the bottom, aren't they? Isn't that what happens when you have negatives? Don't they go to the bottom?
Then you gotta take the other ones.
And this one is coming up.
Oh man, the games have changed.
So now I have, if I rewrite it a little bit, I have a 10 to the 5th and a 10 to the 10th on the top,
15.
and I have a 10 to the 8th on the bottom. Now, this is 5 tens. If you wrote this out, it'd be 10, 10, 10, 10, 10. This is 10 more tens. So if I wrote them all out, how many tens would I have all together? 15. There's 15 tens on the top. There's 8 tens on the bottom. If you wrote them all out, which I'm not going to do, and you started canceling them, what would happen? There'd be 7 extras on the top.
Yes.
So my answer is 3.6738 times 10 to the 7. So the moral of the story is I did a lot of blabbing, but basically we simply multiply and divide the number part and then figure out how many tens you've got. Now it can get a little bit more hairy than that. So let's look at the next one. All right, so let's go ahead and multiply our numbers together. So we have 3.85 times 4.96. So I got 19.096. Now these tens are easy. I got 10 of them, and I got 13 of them.
23.
So altogether I have 23 tens. Now, why am I not done with this problem? What is wrong with this? What? It's not in scientific notation. Do you see that?
There's an extra decimal.
Yeah. If you're writing your answer in scientific notation, this isn't good, right? This is the right answer. We made no mistakes. This is the right answer. But that's not scientific notation. Okay? So this would have to be 1.9096.
Times 10 to the 24.
Right? Times 10 to the 24. Now, some of you are saying, okay, Mrs. Ford, I get that the decimal point's moving one place, so I know that number's going to change by 1. But how did you know to make it 24 instead of 22? Because I know it's going to change by 1.
Right. They're going left, not right.
Okay, and if all that makes sense to you, if you remember all that left-right stuff, that's awesome. But here's how I think about it. Whatever I write here has to be the same as this, right? It's got to be a different version of this. When I went from here to here, I made that number smaller. So to keep everything equal, if this half of the problem got smaller, then this half of the problem has to get bigger. Otherwise, they won't be equal to each other. So when I made this number smaller, by 1 decimal place, I had to make this one bigger by 1 decimal place. So if I had done a problem and got 0.0832 times 10 to the 17th, if that's when I typed it in on my calculator, that's what I got, then I would have to rewrite this as 8.32 times 10 to the something. Now, how many decimal places did I have to move? 2. So this is going to change by 2. Now watch it. Did this number get bigger or smaller? Bigger. And if this got bigger, then the exponent has to get smaller. What? I multiplied this times this. Okay? Yeah. All right, now, which property do we have? Number 1, what property is that? That's the distributive property. Everybody okay with that?
Yeah.
How about B?
Commutative.
Commutative. That's the commutative property. Now, folks, commutative, which by the way does not have an N, it's not communal, it's not community, it's commutative. The commutative property deals with order. So when you look at problem B, you will notice that both sides are exactly the same, except one side has an x plus y and the other side has a y plus x. I switch the order. When you switch the order, it's commutative. What about C?
Associative.
Commutative. What happened?
You
On one side, it's 6 times parentheses. On the other side, it's parentheses times 6. So what changed? The order. No grouping changed. I didn't regroup anything. It's still x plus y and x plus y in the parentheses. I just changed the order. Number 5, or D. D. It's called the additive identity. Why is it called the additive identity? Because when you add 0, you get the identical thing. You keep your identity if you just add 0, right? That's called the additive identity. What about E? Now look on the left. What's the order? 6, 4, 3? Look on the right. What's the order? 6, 4, 3. That's associative. The order didn't change. What changed was the way I associated or grouped the numbers. Right? If the order stays the same, then it's not commutative. If you regroup, it's associative. That's associative. F. Multiplicative identity. Why is that the multiplicative identity? When you times by 1, what happens? You get the same number. You get the identical number. G.
Same thing. Multiplicative.
Well, it's multiplicative, all right, but it's not the identity, because I didn't multiply and get my number back again. What happened? They canceled, right? It's called the multiplicative inverse. That's called the multiplicative inverse. When things cancel each other out, remember a while ago, we said, what's the additive inverse of 16? It was negative 16, right? What happens when you add 16 and negative 16? They cancel each other out. When things are canceling each other out, they're inverses. They're inverses. And H. What's H? That's That's your distributive property. Gang, remember that the distributive property works both ways. You can either multiply it through or factor it out. That's the distributive property. Okay? Yep.
You said it was distributed as well.
Yep. All right, we got like 2 minutes. On Monday, we're gonna have a little quizzy poo. And you are going to have to be able to use interval notation. So, little practice quiz here. Suppose I said sketch this. And that would be on the number line. All right, what would you do? Sketch it on the number line. What would you do?
Well, first you put -4, you put -5, and you keep an open circle on 4 and then a closed one on 5.
One more step.
And then close.
Color in between. Color in between, right? Interval, got a color in between. Okay? How about this one?
Move the 7 down.
You flip the Y, you flip the one
Here we
Y.
go. First of all, what am I gonna do that for?
Keep it.
Keep it.
Stays right there on the bottom. What happens to my X's?
You get X squared.
X squared on top. Beautiful. Oh, what do I do with this?
Flip it.
No, well, I bring him down. Now, do I do anything with the Y to the 10? No, he stays down there. So I already had 10. I brought 7 more down. So now I have Y to the 17, right?
Yep.
All right, I'll see you Monday. Make sure you have your sheets signed if you haven't already, and be ready for a little quizzy too. Have a great weekend. This is the day the Lord has made. Let us rejoice and be glad.
Mrs. Ford, did I give you the seat? Sign right?
No, I need my seating chart. Yeah, I don't know where it is. Okay.